Okay. Hello to everybody on the stream. You have only missed my intro talking about what we're going to be doing. So yeah, data types, data formatting, and why they're important. So in Python, there are three broad data formats that you're going to interact with most commonly. Two of them are numeric, int and float, and one of them is text, strings, is what Python calls them. So let's start with the numeric data types. I'm going to just pop down out of this cell. If you don't have those files, you'll have an opportunity to grab them at the beginning of next workshop too. So, ints and floats. Floating point numbers are, if you're handling data, probably the one you're going to encounter the most. Floating point numbers are numbers that include a decimal place and some significant figures. So if I was going to make a variable called SumFloat equals 6.78, and then if I were to use, 1 second, yeah, okay. If I were to underneath that type, and then some float, we can see that Python knows from this number having a decimal point in it that it is a floating point number stored as a float. Integers, on the other hand, never have a decimal point. They're whole numbers. So if we were going to make a variable called SumInt and call it 6, and then SumInt, Python knows there's no decimal point. The type is an int. This function I'm using here, type, fairly self-explanatory. You can pass it a variable or a data structure, and it will return the type of variable or data structure that you pass in. So an important thing to know about ints and floats is if you try to store a float as an int, if you change it at some point, if you have, for example, a column of floating point numbers that you change to a column of integer numbers, everything after the decimal point will get lopped off. So we'll see more what that looks like later, but it's important to know very early going into this that if you're not careful with your data typing, you can lose a lot of data. Likewise, if you cast an int to a floating point number, it'll tack on a decimal 0 to the end. Again, we'll see more what it looks like when you switch data types, but it's important to know going in that you can lose data this way. Additionally, if you have a column that is all floating point numbers in your data frame, Python will, or sorry, rather, if you have a column that is a mixture of floating point and integer numbers, when you import that into a data frame, Python will automatically assume that it's all floating point numbers. It'll make that a floating point column. That's because, first of all, columns can only have a single type in Pandas data frames. You can't have mixed type columns. And second, because it's safer that way. If Python and Pandas assumed that it was a column of ints, you'd lose a lot of data. So that's integers and floats. The other one that we want to touch on before we continue is text. Text in Python, Python refers to them as strings. Pandas refers to them as objects. So if you're looking at a string, or if you're looking at text data in just raw Python, it will tell you it's a string. If you're looking at it within the context of a Pandas data frame, it will tell you it's an object. We'll see more of that later. So if I were going to type some string, call that 10.23, the quotation marks there are what indicates to Python that it's a string, the same way the presence or absence of a decimal point can indicate to it that it's a float or an int. And if you type some string, it prints out str, which is just short for string. Useful to know, although our string in this case contains a number, we can't do math with that number because it's text. It's not a number. Okay. So before I go on, I see we've got a question back there. What's up?
So instead of 10.23, if you had actually included some text, like not a number,
Yeah.
what would happen?
Oh, so the question was if we actually put some text in 10.23, what would happen? So is not a number. Thusly? It still is, Python still registers it as a string. It's all string data. We just can't do math on it. We can't, for example, do, if, I'll get rid of this briefly just to demonstrate my point. So some string plus 2, we get this error, a type error. Can only concatenate string, not int, to string. The reason for that is that the plus operator means, what this error is saying is, hey, I can't concatenate an int onto a string. And that's because this plus operator in the context of a string is not addition, it's concatenation. So putting two strings together. But if I were to do this, for example, plus is not a number, number, that will work. That will generate a complete string because it's a string.
And those inverted commas are essential when we have strings, right?
The quotation marks are what you need to indicate that a variable is a string, but I believe you can use single and double quotes, single or double quotes. You can't mix your types, but in terms of defining a string, single or double quotes will work. Now, I know some languages do draw a distinction between strings defined with single and double quotes. PHP, for example, will do some kind of strange things depending on which kind of quotes you use, but I don't think Python does anything specific with them. Yeah, not at this level. So for the purposes of this workshop, single and double quotes can be used interchangeably. Are there any other things people would like to know before we keep rolling? Everything seems to be going fine? Perfect. Okay, so now that we know a little bit about data types and what they're like, we can start exploring the format of our data. So the first thing I'm going to do is re-import our data, which means I'm going to have to import pandas as PD. Ordinarily, you'd do this at the top of the file, but it will work here as well. But it's good practice to have your imports at the top of your file. In fact, I'm going to do that just so that I don't teach you any bad habits. I'm going to go back to the top of my notebook. I'm going to put that there, and I'm going to run that there. So there. Now we should be able to import surveys, df, the way we've always been doing it, equals pd dot read underscore csv surveys dot csv. We do that, and our surveys data frame, I'll print it out just so that we can make sure it's all here. There it is. The data you know and love, it's surveys data frame, once again. So, suppose we want to explore the formats of data inside of our data frame. Well, the first thing you might think to do is use that function we used to such wonderful effect earlier and try type surveys df. That returns this slightly long name, pandas.core.frame.dataframe. That's because surveys df is a pandas data frame. That's what it's telling us. If you pass your data frame to the type function, it will tell you, hey, it's a data frame. But it doesn't tell you anything about the data that's actually in your data frame. If we want to find out more about the data that's actually inside of our data frame, we have to use the following syntax. Surveys underscore df. We're going to use those open square brackets to indicate that we've got, to indicate that we're accessing a column. Let's take a look at the sex column. And you're going to type dot, period, d type, which is short for data type. So if you want to get the type of a column, I'll run that and scroll it up a bit so you can hopefully see a little better. If you want to get the type of a column, this is how you do it, by accessing the d type attribute of that column. And in this case, Python is telling us that the d type, data type, of the sex column is O, which is short for object. And also looks like a little surprised face, which I don't know, always makes me smile. Yeah, take joy where you can find it sometimes. Anyway, so that's how you access the data type of a column. That's how we find out what's in a column. We can do this as well with the other columns, just to show you what that looks like. If I delete sex and type in record ID, we can see our data type for that column is int64. Now that may look a little unfamiliar given that earlier up at the top our int type was int. So you may be wondering what that 64 means. It just means that 64 bits of memory have been allotted to store that int. Pandas just uses a slightly different naming convention for its data types than raw Python does. Instead of strings, it uses objects, that O that it showed. Instead of int64, or instead of int, it'll show you int64, and indeed instead of float, it will show you float64. But int64, it's still ints, float64, still floats. It's just also telling you how much memory has been allocated to store that variable. Oh, I'm sorry.
What's the difference between d-type and d-types with an S?
D-types with an S? Oh.
Is there any difference? Because in this case it gives the same result.
You mean just like that? Interesting.
D-types would be the types of all columns, but where you're telling it only this certain column, you still only get that one column.
Okay, so if you select kind of like 2, 3 columns,
Or if you put nothing that's in the, as like...
Right, if you refer to the whole data frame at once,
Yeah.
thusly. The question for the stream, incidentally, was what's the difference between d-type and d-types, plural? So if you want to see, the data types of everything in your data frame, you can use d-types. That will show you. I do think it would work if you index record ID, and just for fun, let's put weight in there as well. If we index all three of those, oh, it actually throws an error.
That's more about how you index it than about...
That is correct.
when you try d-type here, you have to put double brackets.
That is exactly correct. We need to pass in an array, or a list rather, of column names rather than just the comma-separated column names. So if we do that, there we go. So sex is an object, as we've seen. Record ID is an int, 64, as we've seen. And there's weight, which is that float 64 that I just mentioned earlier. So yeah, brief introduction on how to how to return information on your on the data in your data frames. One other thing before we go on, if you're wondering why we didn't use type on the column the way we can use on a variable, We've seen that when we use type on the entire data frame, it tells us it's a data frame. If we use type on the column itself, like if we type type, and then surveys df sex, if we run that, it tells us it's a pandas core series series. That's because the type of the individual columns is series. So the data frame object contains columns, each of which is a series in its own right. But yeah, if we want to get the data that's actually inside of the, if we want to get the type of the data that's inside the data frame, we need to use that dtype or dtypes variable, or attribute, sorry. And because columns can only have one type in Pandas data frames, it will tell you, hey, everything in that column is of this type. And yeah, just to queue myself up for this, surveys df.dtypes. If we run that, we can see most of our data is int. We have a couple of floats, and we have a couple of strings, a couple of objects in there. So now that we know what data we're working with, what types of data we're working with, what are your questions before I move on? Anything else you'd like to know or have expanded on? Anything not clicking? Yeah, what's up?
The difference between object and string, why the sex is not considered a string?
Okay. Okay, the question was, why is sex considered an object and not a string? The reason is just that Pandas has a slightly different naming convention for its variables. In this case, object and string mean the same thing. Pandas will print out object for any as the data type for any column that contains string data. But it's just what Pandas calls it in this instance. It's still string data, and it will behave as a string if you were to pull it out and manipulate it. So it's just the naming convention. It's the same reason that it's int64 instead of int. Further thoughts? Comments? Questions? All right, cool. Okay, so let's cover a little bit of how to work with integers and floats and avoid some of those caveats that that I mentioned earlier. Okay, good. So we know we can store data, numerical data, in one of two ways: integers, which are whole numbers without decimal points, or floating point numbers, floats, which are numbers with decimal points. Which data type we ultimately end up using can have implications for the kind of math that we can do with the data. Integers behave pretty much how you would expect. If we say print 5 plus 5, that gives us 10. If we print 24 minus 4, we get 20. Fairly straightforward. Integers are the numbers we count with, so math with them is very familiar, very straightforward. An interesting thing to know, though, if we do this, whoops. If we were to print 5 divided by 9, what do you suppose will happen? Anybody want to take a stab at it? We know that if we know that integers never have a decimal point, don't contain fractional values. So what do you suppose happens when we divide two integers in a way that does not result in a whole number like this? That is correct. Python will automatically convert the number into a float and return the most useful version of that information. If Python left the data as an integer, you would lose everything after the decimal point, and 5 over 9 would return 0. But Python very helpfully casts the data to a float, so we get the answer that we were expecting. And that works too for division that'll give us an answer above 0. If we print 10 divided by 3, we get 3.3, on and on and on and on and on, 5. Now, I mentioned earlier that we can convert between integers and floats. Useful to know how to do that. There are two functions that we're going to use that are just called int and float. If we want to convert a floating point number to an integer, for example, if I have a variable I'm going to call a, I'm going to say that equals 7.83. Underneath that, I'm going to type int a, and underneath that, yeah, okay. I'll just run that, and you can see we've got 7.83. When we cast that to an int, we lose the 0.83. So when we take a floating number and we turn it into an int, we lose whatever's after the decimal point. As I said, useful to know, you can lose data if you're not careful with how you cast your numbers.
So it doesn't round?
The question was, does it round? It does not. It will just, it takes the number and just lops whatever's after the decimal point off. So 7.83 just becomes 7. Likewise, if we want to go the other way, if we have a variable called b, we say that equals 7, and then we use the function float, and we pass that our variable b. We can see it tacks on a 0.0 to the end. So when we go from an int to a float, we get 0.0 at the very end of the number. Because what else would Python put there? It doesn't know that there's any additional information. So also useful to know, if you accidentally cast your numbers to an int from a float, you can't just go right back to the floats. Python does not know what to do with that. The moral of the story is, be careful with your data types. They can hurt you. Okay, so some basic math, some basic ways of manipulating numerical data. Let's actually get down into the weeds and work with some of our survey data. So, we can modify the format of values within our data. The syntax is a little different from what we've been seeing here, but the principle is more or less the same. We saw earlier that our record ID column is all integers. Maybe we would like for it to be floats. Maybe we start storing record IDs with decimal positions to indicate some other piece of information. So we would go into our survey's data frame and index the record ID column, same as we've done. I'm going to give you guys some space on that so that you can see it a little better. Surveys df record ID, and I'm going to say that equals surveys df record ID, and I'm going to type dot as type float 64. The 64 is important here because remember that's how Pandas refers to float numbers, not just with float, but with float 64. So essentially what we're saying here is I want you to get the surveys or the record ID column from the surveys data frame, and I want you to set it equal to the column, but as a float rather than as an int. And if we go and after performing that operation, ask surveys df what data type the record ID column is with the syntax d type. So if we run that, we can see we've converted from float 60 or from int64 to float 64 here. So we are going to give you an exercise to do on your own here. Here's a little exercise to try on for size. Can everybody see that text okay? Is that big enough? You want me to a few more notches? There we go. So have a go at converting the plot ID to floats using this right here, this syntax, similar to what we just did. After that, when you got some results from there, try converting weight to an integer. And I don't want to give up the game too much, but something will go wrong. And use it as an opportunity to think about what Pandas might be telling you with that error. And we'll give you a few minutes to work on that, and then we'll circle back, check in, see how you're doing. If you're running any problems, feel free to take that red Post-it note, slap it on top of your laptop, and we'll be around to help. Okay, we've all had a few minutes to think that one over. Anybody want to describe their findings? Talk about what they discovered? Let us in on their big adventure with data, if indeed it was. Thoughts on the error that was returned when you tried to cast weight to an integer? Anybody have any thoughts on what may have gone wrong there?
So it won't convert an integer because there's null values in the weight column?
That is correct. For anyone who didn't hear, we get this error that I will show you right now. If we were to go back to our notebook and type surveys underscore df dot weight dot as type, and we cast that to int 64, and I'll give that some space so you can all see. We do that, it throws this error, which says cannot convert non-finite values, NA or inf, to integer. And as you correctly identified, basically what this is telling us is there are null values in the weight column, and Python doesn't know what to do with those when it comes to converting into an integer. It doesn't know how to take something that's not a number, which is what NaN stands for, and make it into a number. Doesn't know what value to assign it. So, further? Okay. All right. So with that as a springboard, let's talk about those null values, because Python gives you a few ways to deal with them in a way that will make some sense for your implementation. It'll let you handle your data in a way that's a little, a little more authoritative. Let you really take charge. So yeah, we get this value error about not being able to convert NA to integer. As we've talked about earlier, NaN is short for not a number. It's a placeholder that Python uses to substitute in for any undefined values that it can't represent mathematically. So for example, when you read in CSV data with Pandas, Pandas will assign any empty cell in your CSV a nan, because there's nothing in there, but it needs to have something there, otherwise the shape of your data will be completely off. So it drops this placeholder in there to let you know, hey, there wasn't anything in this cell. It's null. I don't know what to do with it. This can be useful because Python will ignore NaN data by default. For example, if we took the average of the weight column, if we were to take the mean value, Python would automatically ignore all of the NaN values and just know not to put them in the mean. So the mean that we would get from that, in spite of all the missing data, would still only be the mean of the data we have, because Python knows to exclude the null values. So if, we can see this now, if we type surveys, df weight, we get the weight column, type mean, use that function to generate the mean. If we do that, we can see we get 42.672, etc. So it's not necessarily apparent just from looking at this, but this is the mean of the data that we have. The nans were not included, so great. We've only got the data that we actually have being taken into account. So dealing with missing data values can always be, it can be a little weird. Sometimes it's hard to know why values are missing. If you didn't go and collect the data yourself, if you get it back and you've got missing values in it, it's hard to know why those values are missing. Was it a data entry error? Were they not able to collect the data? Did they get it and then drop their sheet in the water and then they had to take it out and just guess? Sometimes it happens. You never know. The field's a dangerous place. And once you know that the data value is missing, it can be hard to know what to do with it. Do you make it 0? Should you find some kind of placeholder value? What should you do with it? Knowing more about how null values are represented and what to do with them is really important when it comes to making good decisions with your data set and getting authoritative, meaningful results from your manipulation. Fortunately, Python gives you some ways to interact with your null values and handle them differently. So one thing to note, like I said, Pandas will treat any empty cell as a null, not a number value. However, it is worthwhile just on the data entry side of things. This is like before you even get to the point of manipulating it. It's useful to know what you're going to treat or how you're going to treat null values at the data level. Have something to mark them. Should they be 0? Make them 0 as you're entering the data. Have a string that says no values, no data. It's useful to be able to do that before you've even entered the data, because then that precludes having to deal with null values in your code. But fortunately, the code does give us ways to deal with them if we need to. So the first thing we might want to do is figure out where the nans are in our data. So fortunately, we've got some tools in our arsenal now that will let us figure out how many rows have a null value for weight. So let's, and we can also create a subset of our data using some of the tools that we've learned. We can create a subset that only contains weight values that are greater than null, greater than 0 in this case. So let's take a look at how to do that. So if we use the len function, short for length, and tell us how long a given data set is, surveys underscore df, and then you'll remember that we can select not only on indexes or column names, but also on criteria, on Boolean true false values. What we're going to do here is pass in pd dot is null. I'm also going to just ratchet this up a bit so that you can see it better. So pd dot is null. We're going to open our brackets because that's a function. And we are going to put in surveys underscore df dot weight. So you'll recall the notion of creating a mask for our data frame, which is an object with the same size and shape as the data frame that we pass it, but with true false values instead of the data that's in there. That's what we're doing here. If we do this, it returns 3,266, which is the number of rows in our surveys data frame where the weight column is null. We can also do the inverse if we want to determine how many rows have non-null weight values. One of the ways we can do that, since we know we're dealing with this particular method flows sort of naturally from knowing what kind of data we're collecting. If we type length, len, surveys, data frame, surveys underscore df, and this time the criteria we're going to pass is surveys underscore df dot weight is greater than 0. We know that any non-null value is going to be greater than 0 because we're measuring weight. An animal can't weigh 0. That's just not how weight works. So the reason I bring that up is because you can imagine a circumstance in which just measuring greater than 0 wouldn't necessarily give you all of the non-null values. It works in this case because of the kind of data we're collecting. But if you were counting number of legs, for example, on your animal, and one of the species you were tracking was a worm, an animal might have 0 legs, and this wouldn't be non-null. But in this case, we run that, we get 32,283, which is the inverse of our previous one, which is that, which is rather all of the columns that have a non-null weight value. And in fact, if we add those up, 3,266 plus 32,283, we get 35,549, which you may remember is the number of rows in our survey's data frame. So, useful. We can get the number of null values. We can get the number of values that aren't null. We know that we get the right number of entries overall. But how do we get rid of those null values? How do we work with those to make our data set better, tighter, leaner? Pandas provides this function called fillNA, F-I-L-L-N-A, short for fill nan. I'm going to start off before I do this just by making a copy of my data. You'll remember that to make a copy of a data frame, you need to use the copy function. If we just use equals to create a new variable, df1 equals surveys df, we actually get a reference that points to the same memory location. So any changes we make to one data frame will be made to the other. We don't want that because we're going to be hacking up our data set fairly extensively. So we are going to make a true copy of our data frame so that our work is preserved. We can go back to it when we need it. But now that we've done that, let's get right in and mess up our data set. So if we go on that new copy that we've created, we go to our weight column, which we know has a lot of nans in it. So df1 weight. Give that a little more height so you can see. So df1 weight, we're going to say that equals df1 weight, the column, and we are going to say dot fill NA 0. So what this does is it'll go down the weight column and fill in all of our nan values with 0. We do that. It doesn't produce any output, but if we print df1, we can see all the way over here in our weight column, all these values that used to be nans are now 0.0. 0.0 because the column is a float 64 rather than an int, and 0 because we just told it to fill in all of the nan values with 0. So great. We have no more nan values in our weight column. Does anybody have... Can anybody think of a problem that this might cause? Anybody able to pick out a problem that that may arise from this, adding so many zeros to our data like that? Exactly correct. It can completely skew your average. If we do what we did before and type df1 weight dot mean. If we do this, just what we did before, we get a completely different value. The first time we ran this, we got 42.6. We now get 38.7. By adding so many zeros to our data, we've completely changed the character of our results. So that's not great, because in a float column, the Pandas knows to ignore nans when it's calculating the mean. It doesn't know to ignore zeros, because zeros, it's just a number. But the good news is we can pass any value that we want to fill NA. We don't have to pass 0. We can pass in anything. For example, we could choose to fill all the null values with the mean of that column. The way we do that, I'll just put some blank space in there so we can see. So once again, we're going to refer to df1 weight, And this is where it becomes apparent why I wanted to create a copy of the data, because our data frame 1 values for weight are completely messed up. So we're going to have to refer back to surveys underscore df weight to get the correct value. We're going to type fill NA, and we're going to pass that surveys underscore df. We're going to index the weight column, and we are going to get dot mean. So what this is going to do is it's going to take the mean of the weight column. It's going to generate that number. It's going to use that to fill every null value in the surveys df weight column. And then it's going to make df1 weight equal to that. So essentially, it's going to go through the weight column of df1, replace every value with the mean of the original column. Every null value with the weight of the column. Sorry? I thought I heard someone say something. So if we do that, and then we, all right. We do that, and then we type df1, open brackets, weight, dot mean. We can see we get 42.6 again, because we've replaced all of our null values with the mean value of the data. So it doesn't change our mean at all. It just gives us more data that will functionally be ignored by the mean calculation. So just before I continue, what are your questions? Anything you'd like to know? Anything not making sense? Problems you're running into? Clarification? No? Okay, cool. So the point of all of this is to make conscious and conscientious decisions about how to manage our missing data. There's all kinds of pitfalls that you can fall into when you have data that you're missing. And it all comes down to the kind of data you're collecting and the kind of data that you're, or the kind of conclusions that you want to draw from it. Both of those things are going to influence what you do with your missing values. So Python gives you a lot of opportunities to manipulate the null values in your data, get rid of them altogether, but it's on you to know what you're doing and why that's going to be right for your data set. So before we continue on, we've got another thing for you to take a look at and work on. Try this on for size. Try to count the number of missing values per column. And there's a little hint here. Dot count will give you the number of non-NA observations per column. We also have this isNull method, which will help you out. So with those functions and what you've learned, have a go at trying to get the number of missing values per column. We'll give you a few minutes to check that out. Alrighty. Okay. So, anybody want to share their solutions for how they counted up the number of missing values per column? Anybody got a way that they want to show off? Something that worked super well for them? Let's see.
Yeah, but I didn't make it. I cannot make it with his number, so I used the drop NA.
You used drop NA?
So actually, I printed so the length of each column minus the length of drop NA of each column.
Oh, interesting.
Because count and is null in the same sentence, I keep getting errors.
Okay. Yeah, I did not use count and is null together, but that's an interesting solution as well to return the length of the column minus the length of the column with the drop NA function. Drop NA will, I believe, it will get rid of all the NAs in the column, but I believe it will also return how many there are. So your length of your column minus the number that you get from drop NA will be the number of non-null values. The way that I have done it, just to show you this, you can actually do surveys underscore df dot is null, and then once you've got this, you can just type sum, which we covered all the way back in the first lesson. If you do that, that'll give you the number of null values in each column. And you can see there's your verification right there. 3,266 is the number of the number of null values in the weight column. Surveys.df.isNull, I believe, returns a data frame with the true and false, where it returns a mask of the data frame with true and false where values are null. I can show you what that looks like. Surveys.df is null. So you can see over there in the weight column, we've got a lot of trues because there's a lot of null values over there. So once we have this data frame, this mask, we can use sum the way we would use it on any other data frame, and it will return the number of true values in each column.
So I thought that we should use the count and is null in the syntax, and while with sum it counts only the positive, with count it gets all the records. It doesn't matter if it's true or false. So if you do the exact same syntax, is null dot count. So change the sum of count. It actually sums all.
Yes, I hear what you're saying. If we do sum, you're saying to do this? Yeah.
So it actually counts for the line, while the sum is just kind of like 0 and 1.
Yeah. Sum will treat false and true as 0 and 1, sum them together. Count will return the value of non-null, or it will return the number of non-null values in your column. So the reason this returns just the same number, the number of records for all of these, is because within this is null mask, neither false nor true count as null values. So every value is non-null, so count will give you 35,549. We can use count in this other way that'll give you the same output. We can type length surveys df. It's the length of our survey data frame. And we can do minus surveys df dot count giving us the number of non-null values. So the length of our surveys data frame minus the number of non-null values in our data frame will return the same values as before. That'll give you the number of null values because it's your total number minus your non-null values gives you your number of null values. So a couple different ways you can count up the number of non-null, or rather the number of null values in your data frame. We're coming up on time here, so I'm just going to show you one more thing before we jet, and that's how to write out your data to a CSV. We've seen how to read data in, so let's just do that one more time to make sure that we've got the right data set. Surveys df equals pd.read CSV. Surveys.csv. Should be fairly familiar by now. So we've got our data back. So it's clean. We're not mixing anything up. And now, just for the purposes of generating a different data frame, let's use that function you identified, dropNA, which will remove rows. It will remove all the rows in your data frame that contain missing data, even if it's just one column missing. So let's say dfNA equals surveys df dot drop, whoopsie, sorry, surveys dot df dot drop, drop NA. There we go. We run that, and if we take a look at our dfNA, we can see we are missing a whole bunch of indices, and we also have fewer rows than we did before because we've dropped everything that contains a null value. So now that we've got a different data set, we've got, sorry. Oh, yes, sorry. Yeah, so sorry for if I went by this kind of quickly. Drop NA is the function. So now that we have our data without any null values, we can use dfNA, and there's a function called to_CSV. I'll give you some space to look at that. to_CSV. And I'm going to call that surveys no null.csv. So it'll write out that data frame to that file name, that CSV. And I'm also going to pass in index equals false. All that will do is tell Pandas not to include a new row for the index. If we don't include index, or a new column for the index, I'm sorry. If we don't include index equals false, this row here of the data frame index won't be, if we don't include index equals false, this index row will be included in our output. In this particular case, we don't want that, but again, it's on you to make decisions about what's going to be right for your data. So if we do this, there's no output, but if we go to our root folder, I'm going to pop out here to my my root where I've got all my notebooks. We can look at no null.csv, and we can see there is our CSV data with none of the null values preserved. None of the rows containing null values preserved. I'm not going to scroll through the whole thing because there's 35,000 rows. You get the idea. So that is what we're going to cover today. We finished up the unit. We've learned a little bit about data types, what kind of data types are available to you in Python, how you can deal with them, as well as some of the ways you can deal with null data in your data set. That's all we've got for today. Come back next time and we'll show you how to concatenate data frames, stick them together, and make bigger, better, more complicated data frames. Before you go, if you haven't signed in, please do. We've got that sign-in sheet just over there by the helpers. And we would really love it if you could give us some feedback. If you take the Post-it notes next to your desk or next to your laptop and just write one piece of constructive, helpful feedback, or one piece of constructive feedback, something that didn't work out for you, something that maybe you'd like to see improved. Write that on one of the Post-it notes, and on the other one, write something that really worked for you, something that made the workshop really, really click for you, something you liked, anything like that. And then just take the feedback, stick it to the door on your way out, and we'll collect it and read it and use it to make a better workshop next time. So, go back to the code here. So, fill out the sign-out sheet, leave us some feedback. Hope to see you all back next week.